All right, welcome to class. With us today, we want to discuss physics, case 1 in physics, where we want to discuss current, electricity, and its calculations. So these are few of the calculations involving WAEC and other questions for us to discuss. But before we do that, let's discuss some few things, some few key points. Let's discuss some few key points. So, key points. First, let's talk about current electricity. Let's talk about current electricity. So what is current electricity? We say current electricity can be defined as the rate of flow of current. Current electricity can be defined as the rate of flow of current, in a conductor or in a metallic conductor, as the rate of flow of current through or in a metallic conductor. Full stop. So mathematically, we say current, which is I, is given as quantity of charge, which is in Q, all over time taken, which is T, which is small t. So what do we know going forward now? So we say I, which is this one, is also given as this one, which is our quantity of charge with this one. This is it. So this becomes our equation 1. This is what we need to note as our equation 1. Now, please also note this. Your current, which is I, current is measured in ampere. So we take the first letter A to represent ampere. Next, quantity of electricity, which is Q. Q is quantity of electricity. Is measured in coulomb. Which we use as big C. This is big A. This is big C. And then time is our S, which is measured in seconds. So it's S here. So these are their units. Ampere, current here, this current is represented as I and is measured in ampere. Take the first letter in capital letter, which is ampere. Second, quantity of charge, which is Q, quantity of charge, which is Q, has a unit of coulomb. And coulomb is having the first letter, which is capital letter C, representing your coulomb. And then T is for seconds, which represents your small s. So this is the first thing we need to note. And this is the formula. So where we say current electricity can be defined as the rate of flow of current through or in a metallic conductor. So this is the first equation that we are going to be using to solve. Next point to note. Number 2 point is we want to discuss Ohm's law. So there is a relationship between Ohm's law or current and Ohm's law. There's a relationship between current and Ohm's law. So what is Ohm's law? We say Ohm's law is defined as the rate of flow through a metallic conductor. This is defined as the flow of current electricity. Let's put it like this. This is defined as the flow of current electricity and is directly proportional as the flow of current electricity in a conductor, please, as the flow of current electricity in a conductor, and it is directly proportional to the potential difference. It's directly proportional to the potential difference across it. Directly proportional to the potential difference is directly proportional to the potential difference, in bracket, put voltage if you like, across it, provided temperature is kept constant. I go over that again. Ohm's law is defined as the flow of electric current through a metallic conductor, or in a metallic conductor as you want, and it is directly proportional to the potential difference, in brackets, put voltage if you want, across it, voltage across it, provided temperature is kept constant. So mathematically, we say V is directly proportional, I directly proportional to V. I, which is current, please, directly proportional to V. So when I want to eliminate this proportionality sign, if I want to eliminate it, I want to remove this proportionality sign, we simply introduce this. So I have this. We simply introduce this here. In another way, you can also write this like this. We'll say V directly proportional to I. Yeah. And when you are removing this, V becomes IR. Please, let's take this one. V becomes I. Let's take this one, please. This is the correct thing. Let's take this one. V becomes IR here. So this is my Ohm's law that shows the relationship between potential difference, which is V, your voltage, I told you in bracket, and current with also a resistor. This is it. So from this point here, we say our V is given as our potential difference, potential difference, and it's measured in, please, the unit here is still voltage. So that's why I wrote V. Is voltage. Is voltage. Is voltage. So this is the unit. Unit is measured in voltage, so you just put V. Next, I, obviously, we know that that is my current, and it's measured in ampere. This one is measured in ampere. R is a resistor and is measured in ohms. This is measured in ohms. So this is what we need to note, please. This is what we need to note. This becomes my equation 2. So this is all what we need to note to solve this problem on the board. So with that said, let's quickly solve the problems on the board. So I'm going to do some, and I will leave you to solve the other one, and also drop it in the comment section. I am there. I promise you, I'll be there to solve it and post to the correct answer in the comment section as well. Please do well to solve the other ones I will give to you as a practice question, and then for you to also master how to solve case 1 in electricity. So let's quickly do that. Let's do that. So let's go ahead. So here, number 1, we are told that, don't forget the both formulas we just brought out. We are told that a charge of 100 coulombs. So that means that my Q has been given charge of 100 C, capital letter C. Remember I said your Q is quantity of charge and it is represented in coulombs, big C. So Q has been given here. A charge of 100 coulomb flow through a conductor in 20 seconds. So that is my time. Seconds, I told you, time is measured in seconds. So this is it. So we are asked to find the current. Find the current. We don't know the current. So we want to know the current that we would have here when a particular amount of charge is released, and then in a particular time, what will be the current that we are going to have? Simple. We just say recall here. We say recall that we just said that I is equals to quantity of electricity over T. So this is what we are looking for. So I'll bring this one down. Here, I'll put 100 here. I'll have my 100 here. All over time, I'm having my 20 here. So that this can take care of this. This will give us here, I have it as 5 ampere. So this is the amount of current that will be generated when charges of 100 or charge of 100 is released in this time, in this seconds. This is what we are going to have as my answer. It's very simple. It's very, very simple. This is it. So try and recall the formula, and it's easier for you to solve this. Now, question number two. Question number two. So I'll take this off. Question number two. Question number two. We are told that calculate the quantity of charge. This time around, I want to find Q. Quantity of charge is very simple, like I told you. Calculate the quantity of charge, which we don't know, flowing through a conductor if a current, so current, which is I, has been given to be 10 ampere. Remember, I told you that current is measured in ampere. We just take the first letter in capital A, the first capital letter, which is A. So ampere, they said, passes through a conductor for 10 seconds. So time has also been given. Like I told you, these are wire questions. So this one is a wire questions, and that is what we are doing. This is our wire question and other related questions. So we have this. So how do we then solve this one when we have this one here? Number two, please. That's what we are dealing with, number two. So what do we do here? We just say recall. We say recall that I is giving us this over this. This is what we have. So from here, observe that we have Q here, we have I here, we have T here. That means this is the formula we can use. We cannot use any other formula. So what do we do now? We are looking for this. So what do I do? Let me quickly make quantity of electricity, quantity of charge to be the subject of the formula. If you cross multiply this times this one, I'm going to have Q here, because that's what we are looking for. And then this and this, I'm going to have current and time here. Current and time. So what do I do? I will simply say, what is my current here? My current is 10. Please, your current is I. What is my time here? My time is this. So do that. I'm having 1,000 coulomb. This is it. 1,000 coulomb. This is it. Because the unit of quantity of charge is measured in coulomb. So this is it. So these are very simple questions, and this is why we say we are dealing with case one in physics, describing current electricity. And then this is how you solve this. These are very, very simple questions. So I'm going to leave number three for you. I'll leave number three for you. I'll leave that for you. So I'm going to solve 4 and 5. I'll leave that for you. Number three. I'm going to solve 4 and 5. And then please do well to put your answer in the comment section, and I promise to get back to you. So let's go over this. Number 5. Number 4, please. Number 4. Now let's go over number 4 question, please. Number 4 question. Number 4 question. We are told that find the voltage. So V is voltage. Please also note that I want to find this. I will explain what I want to explain. Find the voltage across 7 ohms resistor. So R has been given to be 7 ohms, carrying 3 ampere. So current has been given to be 3 ampere. So this is it. Now, what do I want to say here? Voltage. I told you that voltage and potential difference are the same thing. That's why your potential difference is measured in voltage, which is V, is measured in V. So if I have voltage given to us here, that means we're looking for potential difference. If you have potential difference given to you there, the same thing we are looking for voltage, they are the same thing. So I'm looking for V, please. V, that's the voltage, V. Take the first letter there. So what do we do in this case? Obviously, we are not using current electricity formula. We are using Ohm's law, because we have voltage, we have resistor, and we have current. So if we are not given Q, quantity of charge, and time. We have no business using that. Here we are giving R. There's no R in current electricity, big R, there's no R there. As well, there's no V there. So in the first formula, you have I equals to Q over T. Hear me, I equals to Q over T. So we don't have V and R there. So for this case now, we are looking for voltage. That means that we are to use this formula. So we say recall that V is equals to IR. So this is what we have to use. Why? Because we have voltage, we have current, and we have R, which is resistor. We are looking for this V. So what do I do here now? I will say V becomes, what is my current here? My current is 3, multiply it by 7 here. So if I do that, I'll have this to be what? 21V, please. 21V. This is it. This is how you do this. I remember I told you that your V is your potential energy, and your potential energy is measured in V. So this is it. This is how you solve it. These questions are very, very simple. They are very, very simple. So solving this one helps you to get the first phase as we dive deeper when we are solving current electricity question. We have a lot of them to solve. So please do well to go through this, and also do well to share. Tell this to your people, your friends, your brothers and sisters. Tell this to your family, your communities around about this channel. And then if this is your first time of coming across this channel, please do well to click the plus sign. It's very important because you're going to be learning a lot here in sciences. So this is it. Now, this is how you solve number 4 question. And this is my answer. It's very simple. Now, let's deal with the 5th question. The 5th question. The 5th and the last question. The 5th and the last question. Now, let's check this one out. They said a current of 100 milliampere, M there is milliampere, passes through a conductor for 2 minutes. 2 minutes. Full stop. They said the quantity of electricity transported is, obviously, let's list out what and what is given to us. So number 5, a current of this. So we have I to be 100 milliampere. It passes through this for this time. So time is given as 2 minutes. As 2 minutes. They said the quantity of electricity. Whenever I hear the quantity of electricity, we are just describing Q. That's all. The quantity of charge or the quantity of electricity, we are just describing Q. Now, what do we know? Please look at this. There are some introduced aliens here that we must convert. Remember, I told you that current is measured in ampere. Now, watch this one now. This one has been introduced to it. This is also a wire question that has been introduced to the ampere. So how do I remove this? To remove this now, to convert this from milliampere to ampere, we simply divide this 100 by 1000. That's what we do to remove this milli. So if you divide that, we are having 0.1 A. 0.1. So this cancels this. This cancels this. So we are having 0.1. So that's my ampere. I've gotten that. Next up, we are told that our time is measured in seconds, not in minutes. Observe that this is a minute. So how do I convert this to minutes? It will interest you to know that we are going to use the playful song we are using. 60 seconds make 1 minute. 60 minutes make 1 hour. That's how you convert this. So to convert from minute to second, you simply multiply by 60. 60 seconds make 1 minute. So if I want to convert this into seconds now, I will just multiply it by 60. Do the math. 2 times this 60, I'm having 120 seconds. So you have converted this into seconds, please. So now with this, we can now calculate our value. So what do we now do? We say recall here. Recall that, observe, we have ITQ. Obviously, we are not using V equals to IR this time around because we don't have resistor, we don't have a voltage here. So we only have ITQ. So we are using the first formula. So that becomes I to give us this value over this. So we are looking for the quantity of electricity. So we'll make this one subject of the formula. So if you do that, we are going to have that. We're going to have this here. Let me take this one off. We're going to have this as I want to make Q, so the formula, which is quantity of electricity. So we know that our Q here becomes IT. IT, where your I is your current and your T is your time. So what do I have as my I there is 0.1 times, what do I have as my time is 120 seconds. So how do I work on this to get my quantity of electricity? So mathematically, observe that before we got to 0.1, we had 1 over 10. Look at this. This cancels this. This cancels this. So we had 1 over 10. When you divide 1 over 10, that will give you 0.1. So I will change this one into 1 over 10 like this. 1 over 10 like this times 120. Why am I doing that? So that I can divide without using calculator. So that this 0 take care of this 0. So that this 1 cancels this 12. We are having 12 there. So 12 times 1 gives us 12 columns. So this is how you solve this. It's very simple. It's very simple. Please, if this is your first time of coming across this channel, do well to click the plus sign and follow for more. And also, the number 3 question is for you. This number 3 question. Do well to solve and put the answer in the comment section. See you in the next class. Bye-bye.